Hi, everybody. Welcome to Building ClickHouse and Making Your First Contribution, a tutorial. My name is Robert Hodges. I'm CEO of Altinity. I'll be your host today at this webinar. The actual content is going to be delivered by my colleague, Vasily Nemkov, who is lead server engineer and has implemented many features in ClickHouse. If you're a ClickHouse user, you've probably used a few of them already. Before I turn it over to Vasily, I'd like to just talk a little bit about the webinar and some things that may help you enjoy it more. First of all, as you probably just heard, this is being recorded. We will publish the recording along with a link to the slides to everyone who's signed up after the webinar is done. You can expect it within 24 hours at the latest. Second thing, we have plenty of time for questions. What we recommend is that if you have questions during the webinar, go ahead and post them in the question and answer box. I'll be monitoring it while Vasily is talking. If it's something that's relevant to what we're covering at the time, we can just answer it then and there. Otherwise, we'll catch them at the end. You can also type things into the chat box. I'll be watching that as well, whatever works for you. This is not a huge group, so we just want you to enjoy the content and have a good time. With that, I'm going to go ahead and turn it over to Vasily. So Vasily, if you want to come on and take over, it's all yours.
Hi, Robert. Thank you. So, as Robert previously mentioned, my name is Vasily Nemkov, and I'm server team lead at Altinity. I've been working on ClickHouse for about 3 years now. Merged about 70 PRs. The most probably noticeable features is IPv6 and IPv4 data types, Gorilla and Double Delta codecs, daytime 64 data type, and extended range for daytime themes. I also recently implemented the system session log thin and many other minor fixes and minor features. I'm working at Altinity. Altinity is #1 enterprise ClickHouse provider. We also provide astonishing support for our users and implement custom features and custom bug fixes for our customers. And recently, we opened Altinity Cloud, which is ClickHouse in the cloud. Probably Robert could tell about this a bit later more. And we also a major committer and contributor outside of, in the US and EU to the ClickHouse repository. So what are we gonna have today? Well, a little bit of overview what we're gonna have. Well, I will tell you a bit about what ClickHouse is, and then we'll just dive right into developing the feature. I will tell you how to clone, how to make the changes in the ClickHouse, how to build it, how to run the test, and how submit a pull request, and how to make it merged. So, what ClickHouse is? ClickHouse is an astonishing piece of software. First of all, it's OLAP DBMS. What that actually means, it's really excels at managing through a lot of data and providing you valuable insights on your data. Like if you ever seen Google Analytics or Yandex Analytics, it runs mostly on something like ClickHouse. So it's able to go through a large amount of data and provide you some aggregates. For example, how many users of the given age cohort were visiting your website and stuff like this. It's widely used by Fortune 500 companies for log processing, time series, financial transaction management, like stock markets analysis, and on and on and on. But also, it's an open source software, which makes it even more greater. It's the fastest growing open source project now. If I recall correctly, in the year 2021, it surpassed the Elastics in the number of committers and number of commits from the outside contributors, if I'm not mistaken. It's written in highly optimized modern C++. It's about 500,000 lines of code if you exclude all the third parties, and also it utilizes about 80 to 84, and I'm not sure about the exact number of third-party libraries and components. It has lots of tests, and it also provides very useful and very detailed documentation, which is also provided in the repository, which you can actually contribute and modify. So why should you contribute? well, probably it is the faster way to build, to implement a new feature or fix some specific bug. Well, ClickHouse is well tested and most of the most common bugs and features are already implemented. But if you have some corner case which is not already covered, you can probably go ahead and try it, figure out yourself and provide a useful feedback to the community and useful fix. Also, since it's very well written, you will not learn a lot in the process. It's a very good piece of software, really clean, not not much smelly code. So well, it's really a joy to work with. Also, you will gain some fame. I don't know if you noticed this before, but ClickHouse has a specific system table, system contributors. So, for example, if you have any merged PR into a ClickHouse repository, you can find your name in the system contributors table. Also, if you would be able to merge anything into the ClickHouse master, you have an opportunity to receive a ClickHouse merge contributor badge from Alexander Milovidov himself, from Alexei Milovidov, I'm sorry, who is originator of the ClickHouse. And well, another notion about ClickHouse, that's a huge noticeable project. It participated in the Arctic Code Vault contributor, in Arctic Code Vault program. So probably it's not operational at 2021, but who knows, probably they will take another snapshot. So if, for example, if you merge anything into ClickHouse before the next snapshot to the something like Arctic Code Vault program, you'll receive a really cool badge, cool badge. So there are multiple ways to contribute. First of all, you can run a benchmark on your software. There is a specific web page which shows all the hardware which used to run a defined set of benchmarks on ClickHouse, and this allows you to compare, well, which allows ClickHouse to be used as sort of benchmark of the hardware. And you can actually contribute, for example, how different hardware competes against each other. You can update docs. As you know, probably the docs is most outdated thing in any software project. You can go ahead and probably, well, the easiest way, probably find a typo and find some missing piece and add it to the documentation, create a PR, and gain yourself a contributor badge. Also, you could probably add some tests. For example, you have some specific thing, if a specific corner case you'd love to test it, and you would love to ensure that this never breaks. For example, if your critical system depends on this, you can contribute a test to ClickHouse and make sure that it's always run in CI/CD and always verify that your particular use case is covered by tests. And the last way, and probably the most useful, is to contribute some code to ClickHouse. So, and we are going to go with contributing the code. The process of the contributing is, well, pretty straightforward. You actually write the code, you prepare a review, and then it gets released. If we break down the development process, it's pretty simple. You clone the repository, you make your changes, you build the ClickHouse, you run the test and add some tests, and you push your stuff to the GitHub. So let's start with cloning. It's pretty easy, pretty standard procedure. You actually clone you actually clone the ClickHouse repository, clone a ClickHouse official repository, and update all the submodules. As I said previously, there are about probably 80 submodules, 80 plus submodules. So it would take about probably 10 to 15 minutes, depending on how lucky you are and how close are you to the GitHub CDN. That was easy. Next thing is a bit harder. We're going to make some changes. According to Alexei Milovidov, there's some sort of complexity hierarchy. So some things are pretty easy to add, some things are pretty hard. Well, things on the left are relatively easy, things on the right are relatively hard. And we're going to honor a venerable tradition of my people and start with adding hello world function. So this is the way. We're going to add a hello world function that prints a simple string hello world. There are multiple guides on how you should develop, how you should write C++ code in the ClickHouse. You can see references, and so you can check out later the links to the docs, which says you what should you do. Since I already navigate the ClickHouse source pretty well, I know that all the functions go to the src/functions directory. So we should add a new CPP file to that directory. I'll show the contents. This is an absolutely minimal piece of code you can add in order to have the function implemented in the ClickHouse. As you can see, the function is a class which implements some specific interface, and there is a lot of boilerplate stuff in order to get it up and running. But probably the two most important parts of this is the function get return type impl, which shows ClickHouse what is going to be the return type of the function. And this time we see that we're going to return string. And the second one is execute impl function, which is actually going to process all the inputs and produce the outputs. As we can see, the function takes 0 arguments and only prints a constant string, produces column of constant string. So this is pretty straightforward. Also, we need to have a register function that is gonna register our function in the function factory, as you could probably see. Function factory is sort of a singleton that dispatches, allows ClickHouse code to access the function instance of the function that you actually want to run. And also you need to register your function in the factory. You can see the diff here. There is a dedicated CPP file, register function CPP, and well, it's pretty straightforward. You just declare the register function hello world, and then in the register functions, just execute it against the given factory instance. So that was pretty easy. What's going to be a little bit more harder is building it. There are actually two ways to build ClickHouse. The first one is to build it in Docker, which is really convenient if you want to produce dep and rpm and touchgz packages. Pretty easy to set up. It only requires a Docker, and it can be run on almost any OS which supports Docker. But it's somewhat slower than more native and usual way to build it. Is build it on host directly. First of all, it's most suitable for development process. For example, if you develop some core ClickHouse functionality like we do here, and it also could be done on some Linux-based distribution. For example, the most recent Ubuntu or distributions based on Ubuntu should do fine. And you also need to have some development packages installed beforehand. And it's about 2 times faster on my machine than building with Docker, since in Docker you're not only building the ClickHouse binary itself, you build all the packages, and that takes a lot of time. Also, since ClickHouse is a pretty big project and it's pretty tough C++ code, a lot of templates, you have to have a pretty decent machine in order to build it. It's recommended to have at least 60 gigs of RAM, and 32 is much better. You should have multiple cores. The more is better. Like, for example, on my laptop with the 6 cores, it's okay. Like, but the better hardware you have, the less time it would actually take to build it. And you also have to have ample amount of free disk space, depending on what exactly are you going to build. If you only build the binaries with the on-host build system, it probably takes about 20 gigs total, about probably 5 gigs of the ClickHouse source code with all the dependencies, and probably about 10 to 15 gigs of the intermediary files produced by the compiler. The overall resulting ClickHouse binary is pretty small. I guess it's under, if I recall correctly, for release builds under 100 megs, probably 200 megs. I'm not sure. but compiler produces a lot of object files and libraries and intermediate stuff, so it takes a lot of space. Also, if you plan to build packages, you have to have even more space, because after building the binaries, it's fed to the special script that builds deb packages and RPM packages, and that tend to produce a lot of more stuff, and that's that wastes a lot of hard disk space. So we are going to go with the easiest path for now, is building it with Docker. Here is the example of how you do it. Well, a few important things to notice here. The first one is the output directory of the whole process. Here is the directory where all of your packages are going to end up. Well, as you can see, I'm running this from the root of the ClickHouse source directory, and I have special directory for the packages like .packages, ./packages, and it's mounted to the output directory in the on the Docker machine. Also, we need to have another directory, which is like this is now a source. This is now a root of the source directory of the ClickHouse, which is mounted to the build directory in the Docker. This is where all the sources of the ClickHouse is going to be. And I remind you that you have to have not only ClickHouse check it out, but you have to clone and check it out. You have to update and fetch all the submodules in order to be able to build it. Next thing is we selecting the compiler we're going to use. As of today, the most recommended compiler is Clang 11. ClickHouse is also can be built with GCC 9 and Clang 12, but this is, I guess, is not most recommended way, because there are some hindrances, probably some issues, minor issues, but still, well, this is the official way you do it. Another thing, another optional thing is to produce RPM and TarGC packages. If you don't want to have RPM or TarGC packages, you can remove this line. And another thing is compulsory is you can also add some CMake flags, which is going to be pushed down to the CMake, and you run that on the specific Docker image, which is provided by the ClickHouse Docker Deb Builder. You can actually build that image yourself from the source directory of the ClickHouse, but as of now, we're going to use the latest one. Since we built in the master, we're going to use the latest one from the ClickHouse Docker Hub. And well, it takes 30 to 90 to probably 120 minutes, depending on your hardware. On my machine, it builds about 1 hour. The best running time I've seen on the beefy AWS machine was 35 minutes. And as a result, well, we have a cinema animation of how it's done. You can see this is CMake phase. It has a lot of fancy stuff. Now, well, there's a build phase, and as you can see, there are so many targets in ClickHouse. It's a really huge project. And then, well, somewhere next to the end, it's producing the packages. Let's go back. So imagine you run the command I gave you previously, and you end up, and your build succeeded. So you end up with a lot of stuff in your package or directory. First of all, it's the deb packages. And as you can see, ClickHouse provides several packages. The first and most important, most probably important one is the ClickHouse command static. This is the biggest one. Well, not the biggest one, but the one which has the ClickHouse binary itself. And ClickHouse client and ClickHouse server packages actually depend on this one. So you won't be able to install ClickHouse server itself or ClickHouse client itself. ClickHouse client and ClickHouse server are pretty slim packages. If I recall correctly, those only contain the configs necessary for ClickHouse to function in either server or client modes. Also, the biggest package of those is the package with the debug info. If you build, if you're building with the debug info, you get the pretty beefy, I guess, hundreds. I guess it was 400 megs or something like this. Package with the debug info, which is useful if you want to debug your installation. And also, auxiliary stuff is a ClickHouse test, which contains all the, if I recall correctly, this was the stateless tests of the ClickHouse, and we are going to return to this later about the testing. Also, the very same theme for RPM packages and very same stuff for TGZ packages. And also some additional files of build info and changes. If I recall correctly, this is the change log and information about the build system was utilized. So, and you can go ahead and install your dip packages or RPM packages on any compatible system and run your server. So the next way to build ClickHouse is to build it on host. In order to do that, you have to have a lot of stuff pre-installed. You have to have a compiler, you have to have a CMake, a special LLVM-based linker, which makes linking at least 2 times faster on my machine. Ninja in order to build it fast, and TZData in order to provide all the time zone information for the datetime and datetime 64 classes. So you just run this on your Ubuntu-based system, and you have all the stuff necessary. And then you're ready to run it on your host machine. I prefer to build ClickHouse to have a build directory out of source, because I tend to have multiple build directories. For example, release flavor, debug flavor, flavor with address sanitizers on, or memory sanitizers on, or like with a specific set of features disabled, all built from the same set of sources. And having out of source build directory actually allows me to do that. And usually I have different build directory for different flavors. But as we are going to build only one flavor default, we're going to have simple build directory. So we make a directory, descending into that, selecting the compiler we're going to use, and run the CMake against instructing CMake to produce build scripts for the Ninja from the sources located in the ClickHouse directory. It takes some time, probably a couple of minutes for CMake to configure everything, and then you're ready to go. You can just type Ninja ClickHouse, and it will build ClickHouse binary. As I said previously, it takes from 30 to probably like 120 minutes, depending on your machine. And in the end, you'll be able. Well, we have another nice animation here of how it's actually done. You can see I'm typing here all the necessary commands like yada yada. This is the CMake phase, and then you can see that Ninja is actually building the ClickHouse. It's gonna take quite some time. This is one of the reasons why I have recordings, because it's impossible to do this live on a webinar because ClickHouse building takes so much time. You can see, well, probably it's like 84 minutes on this machine. So once you have it built, you can check out what's inside the binaries directory, which is build-programs. It has a lot of stuff, and well, I've highlighted for you the ClickHouse binary. The notable thing about ClickHouse is that the single binary can be used both as a server and as a client. It depends, it chooses how it should be executed depending on which option do you provide to it. So I will show you now how you actually verify whether or not your build was successful. Well, the first and most easiest way to actually verify anything is to smoke test it, like to go ahead and run your server. In order to run ClickHouse as a server, you need to have a set of configs. And luckily, ClickHouse itself in its build in source directory has a predefined set of configs, which is pretty enough to run ClickHouse on your local machine. you just go to the ClickHouse programs /programs/server directory, and then start your ClickHouse server in ClickHouse in the server mode in that directory. As you can see, this is the path where the ClickHouse binary resides, and this is argument that says ClickHouse to be running to be started in a server mode. Then you need to open another terminal, and from any directory, from any other directory, or from whatever directory, you just execute ClickHouse, start the ClickHouse in the client mode. As you can see here, it shows that it was able to connect to the server. Well, that shows the ClickHouse client version. It says that it's trying to connect to the server on localhost on this port because it uses the native protocol. If it were using, for example, HTTP protocol or MySQL protocol or a Postgres protocol, would try to connect on different ports. And as you can see, it was able to connect and reports the version of the server. And also it produces some warnings. And since we build the ClickHouse with the debug info in the debug mode, it warns you about that the server is not going to perform on top of its ability. Like it was built with the debug info and it works slowly. And this is the friendly greeting from the ClickHouse client, and you can actually type in any comments here. So let's go ahead and type something. Let's execute the simplest query of select version. That actually sends the query from the client to the server, and the server executes the function. And well, this function produces the screen which shows the exact server version. Well, as you can see, we were able to smoke test whether or not our server works. So we've seen that client actually was able to connect to it. It was able to send the query, the server processed the query and return some results. So it looks like okay, but well, it's not really enough to verify your database system. You want to be absolutely sure that it works as it should. And in order to do that, ClickHouse has a plethora of tests. There are roughly, well, the most important ones we're gonna cover today is unit test, and stateless, integration, and performance. But ClickHouse has many more other tests. Unit tests are usually, well, our C++ tests written using Google Test Framework. They're about probably 40K test cases, and it takes about 4 minutes to run those. Stateless tests are simple enough SQL or Bash or Python based tests that more like functional tests that test ClickHouse end-to-end as sending a request from the client or from MySQL or from HTTP client or whatever else, and verifying what actually server produces and reports back to the client. And there are about probably 3,500 of those tests, and they take about 45 minutes to run. And there are also integration tests, which verify ClickHouse against some more complex scenarios. For example, if you want to test your distributed queries or like interconnection with MySQL or Postgres or whatever else. And also there is a suite of performance tests which verify that ClickHouse works on top of its performance, verifies against some predefined prior version. This is a simple XML files, and if you want to know how to run those, you can check out later the bonus materials which are going to be presented, present in these slides. So, but since we add a new functionality, we want to add a new test which actually covers this functionality. And probably the simplest way is to add a simple SQL-based stateless test. In order to do that, we need to add two files to the ClickHouse source directory. We add the test itself, which goes to the test-query -0 underscore stateless and the number of the test and the name .sql, and it has only one SQL statement. For the reference, SQL tests could have any number of statements in those. Some are pretty complex, some are as simple as you can see those, some are as simple as these. And another thing is that you have to have a reference file, which actually is a sort of thing you compare your results against. So as you can see, we've added a simple test, we've added the reference file, which presents what server should actually, what the client should actually fetch from the server, what string should it actually print upon executing this command. And now it's time to run those tests. Please note that running stateless tests requires a running server. So, it's okay to run the ClickHouse the way I've shown you before, or you can probably, if you build it as a deb package, you can install it and start on your machine. It doesn't actually matter. All it matters is that you have a server up and running, and that clients are actually able to connect to it. So in order to run your test, you go to the test directory, and then there is a special test driver program, which is called ClickHouse test. It has lots of features, lots of handles you can tweak, but the most important ones is the path to the binary, the ClickHouse binary itself you're going to use, which is going to be used at the client in the client mode, and the set of tests you want to execute. If you omit the set of tests you want to execute, all the tests in the stateless directory is going to be run. So this is and this takes a lot of time. So, for example, if we run the ClickHouse test the way I present you here, it's going to run on a single test, and well, it's going to take probably a couple of seconds for the test harness to boot up, to process the test itself, to connect to the server, to verify that it works fine, and then execute the test. As you can see, while the test was executed, output of the client, which was generated by feeding by feeding the SQL contents of the SQL file to the client, matched the reference file. So the test has passed. As you can see, it shows you the test has passed. It took about 2 seconds because the ClickHouse was built in the debug mode. In release mode, it should have taken much less time. So we consider our job almost done. We have added new functionality. We were able to build a ClickHouse. We wrote a test which actually passes. So now it's time to commit and push your work to the repository. Well, and you do it the way you do it with any other project. You just create a new branch for the feature. You add all the files you have added or modified. You commit your code and then push that to the fork. And the reason why you need to push your work to the fork is that you don't have, well, most likely you don't have any write access to the ClickHouse repository, and you have to create a pull request from your fork. So you just push your work to your fork and then create a pull request from the GitHub UI. Once you execute git push, and once you execute git push like this, it's going to give you a nice URL which you can follow to create a pull request. So now we're going to continue to the review process. You can actually check out. I've pushed this code beforehand, so you can check out how the pull request looks like in the GitHub UI. I can demonstrate it here. It's supposed to be, yep, it's supposed to be live. Yep. As you can see, this is a simple pull request with simple description and stuff. I will show you now how to what should you do in order to have your pull request processed. Well, the first thing you will see once you open the pull request is that a template of the changelog of the template of the pull request description mode. You have to edit this one in order to have your pull request reviewed by anyone, because you have to describe what's actually going on, what are you modifying, what benefit it would bring to the house, and pick appropriate category for your pull request. For our simple one, we have something like this. This is the new feature, and the changelog entry is pretty simple because the functionality is pretty simple. So we've set the description, we've pushed the button to create the pull request. Now the next thing we have to do is assign the CLA. And since I have already signed the CLA previously, the GitHub itself, there is a check that verifies that any given user that contributes to ClickHouse has already signed the CLA. And as you can see for me, I've already signed it and the check is green. So if you haven't signed yet, you will see the comment from the special bot, which with the button. You can press the button and follow to the CLA page and sign it. It's pretty simple. The next thing is that once you sign the CLA, somebody from the ClickHouse team sees and reviews your pull request, sees that it's safe to actually execute on CI, that it wouldn't consume too much resources, that wouldn't leak any sensible information. They put a special tag that instructs a special bot to run test against your pull request. And there are roughly about 50 checks, which can be grouped as style checks, which verify that your code follows the style guide of ClickHouse. The fastest is a simplest subset of ClickHouse built and executed against the small subset of stateless tests. There are various forms of builds against different various compilers against various set of options. There are stateless tests which executed against various builds like debug version, release version with edit sanitizer, memory sanitizer, and so on and so on, so on, so on, so on. You can check out more information about types of checks in the reference documentation below. So once you have this special tag, you can see that all the checks has been executed against your PR. And well, this is a screenshot from the GitHub UI, which shows that checks are executed gradually. Not all 50 jobs are added simultaneously. So first of all, executed fastest, and then other stuff as available resources, as resources are available. And for example, as you can see, all the checks here are green, but if some of those fail, you can actually check out the details about what actually gone wrong by clicking this little link on the right side of the check. So for example, this is a review of the check page for the fast test. It has a link to the PR it was done against. It has there's a really long list of the executed checks, and has links to all the necessary information for you to actually debug and figure out what's actually wrong if your check has failed. You can have logs of ClickHouse, logs of builds, of the build process, log of the test process, and whatever else. And all the pages look about the same. This is the page for the stateless test. You can see it has a bit more information. This is the check page for the integration test. You can figure out there was even more stuff, and so on and so on. So you have to, if you have any check failed, you have to figure out what's actually gone wrong. You have to go through the logs and see what of the test has failed and try to reproduce that on your machine, or probably test it any other way. once you have all the checks fixed, or if once you have all the checks fixed and green, you would be able to you should be able to address all the, or probably even before that, you should ever address all the change requests from the ClickHouse maintainers. For example, adding more tests, or probably doing something differently, or probably not. I don't know. It depends on the nature of your pull request. Once you've done that and you have the approval of the maintainer, it's time to merge your pull request, and somebody from the ClickHouse team will actually do that. And you can, as you can see, once the pull request merged, it has this nice purple tag on the top, and while there is a node on the bottom, which says that your pull request was merged, and you actually can pat yourself in the back. But once your pull request is merged to the master, it's not going to be released just yet. You have to wait for its before it's going to be included in the next upcoming release, or if that was some valuable fix of some nested bug, it's going to be backported and then release it almost immediately. Well, not almost immediately, but once the necessary fixes are backported to the appropriate branches. And later on, your fix will appear in the official repo, or probably we can release a fix as a part of the Altinity release process. So this is all the references used in this documentation. And a little announcement: we are hiring. Well, there are lots of open positions. You can check out our careers page. And if you found this presentation easy to follow and you are really good at C++ and database engineering, you can apply for our ClickHouse server engineering position. And I will be glad to welcome you on our team. So this is it. Thank you. If you have any questions, please go ahead and ask.
We've got Vasily, that was a great presentation. Thank you so much. I've only done doc fixes, so it's good to see the build procedure. We do have a number of questions. I'm just going to read them out. They're mostly in the chat. Feel free to, folks, if you've got other things, what we're going to do is spend some time and we'll answer every question we can through the top of the hour, or until the questions run out. So here's one from Ian Watts. If we're making some changes in submodules, is there an easy way to redirect to that in the build? So for example, a local copy of extras. Right? How would you do submodule changes?
Well, there is as for now, submodules is a really fragile thing for ClickHouse. But if you only, contributing that back to the adding new submodules is kind of messy. But each submodule has not each, but most of this modules has actually was forked to the ClickHouse extra repository. And there is so you can for starters, you can make your local changes, and then those are going to be used by the build system if you run this on your host machine or in Docker, because Docker builds and your host machine builds actually use all the stuff you have in your local folder. So if you don't want to push any changes upstream, you're pretty fine modifying your local version of the submodules. But if you want to modify submodules, you have to push a pull request to the appropriate repository.
Okay, I hope that was clear. Here's another one from Boris. Is it possible to build with a distributed compiler like dist.cc?
I'm not aware of anyone building ClickHouse with dist.cc. Probably it's possible, but since this is not official way we do it in ClickHouse, it's probably not the most supported way. For example, if you're trying to build ClickHouse for some exotic architecture, you probably would face some issues, and then once you face those and you fix those, probably you would have to face those again and again once you update your ClickHouse to the most recent version, because those are not actually verified in CI/CD. So the process of building ClickHouse with dist.cc is not in CI/CD, so this is not verified way. Probably it would work out of the box, but most likely it would not.
Okay. Here's another one from Matthias. Is it possible to run some checks offline before creating the pull request? For example, running the style check beforehand to save iterations on builds.
As for the style check, I have not included this in the slides, but there is a utility directory in the ClickHouse sources, I guess, utility check dash style slash check dash style script, and you can run it against your local changes, and it actually would verify. But it's kind of noisy because it also checks some of the third parties, but well, it's workable. And also there is a bonus pages which shows you how to actually run specific tests against ClickHouse. This is how you run unit tests. This is how you run stateless tests. Don't worry, you can see that all in the materials which are going to be provided later. This is how you run integration tests against your local builds. This is how you run performance tests. So, well, yes, you can actually run all those tests against your local build of ClickHouse.
Got another question from Ian. If we have a fix and we want to know what which release it will be in, is there a way to see which targeted branch it is planned for?
Well, this could be pretty tricky because, as I said previously, the bug fixes got backported to the currently supported versions, which are probably, if I'm not mistaken, the current LTS versions and a couple of versions back. For example, as of for now, October 2021, the most recent LTS version is 21.8. The previous one is 21.1 or 0.3. I don't recall which one was exactly. So, for example, if you merge any fix, it would definitely go to 21.8 and probably to 21.3 and also to 20. And since this is October now, it's going to be like in 21.9, and the next version, which is going to branch off the master. And if I recall correctly, the next version is always branched a month ahead. So, for example, version which is going to be released in November is branched off in October. So it's kind of the process is like not solid yet enough. So you have to figure out and check with the ClickHouse team. And they're pretty good. They are eager to answer any ClickHouse related questions. So, for example, if you ask, well, guys, we have measured the fixed or we measured the feature, when it's going, in which exactly version we're going to have it, they will eager to answer this question.
Yeah, and one thing I want to say, because it wasn't really covered in the talk, is there is this distinction between monthly releases and long-term support releases. So the LTS releases are twice a year. Roughly generally 6 months apart. So we had them in 21.3, that was the March release, and 21.8, that was the August release. And what happens there is we make an effort not to have too much destabilizing stuff in that release, and then we just swarm it and test the daylights out of it. And then, as Vasily was saying, bug fixes will get backported into that for up to a year. At Altinity, we actually support them longer because, I mean, realistically, some people, want to run things more than just a year, or have things on support for more than just a year. So, so you'll definitely, for sure, you'll see it coming out in the next monthly release, and then just depending on where it lands, it'll get backported into other things, as Vasily said. Here's a great question. Who backports a fix? Speaking of backports, is the developer delivering to master or CH maintainers? And what is the criterion to determine if a fix needs to be backported?
Well, the criteria is somewhat arbitrary. You have to, well, most of the bug fixes, if those easy to backport, are backported automatically. But if it won't be, if the thing is really critical, well, actually, definition of critical, it depends, it's arbitrary. And well, we have to somewhat convince probably, and I don't know, well, negotiate with the ClickHouse maintainers whether or not this is critical enough to be backported. If it's not easy to backport, well, the answer is it's mostly automatic. If it's critical, it is done by the maintainers. If you absolutely want these to be backported, you probably, but for some reason, maintainers do not think this is a critical, you can help them by backporting it yourself. And then we'll ask again to include that, to merge that in the designated release.
Okay, great. Another question here. Now, this is related to testing from Raj Kumar. Test flows frames are used, or Google Test Frame used for testing ClickHouse? I think the answer is actually a little bit more than that.
Well, thing is, there are lots of testing systems in ClickHouse. The first of all, we also utilize the test flows, but also we utilize the ClickHouse utilizes ad hoc custom testing harness as for the stateless tests, for the performance checks, for stateful tests, for integration tests, and well, for many other things. Also, it utilizes the Google test-based unit test, so it uses lots of stuff, and both Google test framework and the test flows framework are part of it.
Yeah, test flows is something we developed. We like it because it gives you very accurate diagnostics on what functionality you're testing. And that's a pretty effective technique for testing interfaces. But there's a plethora of tests. Here's a great question. And Vasily, I think we may have the topic for the next webinar. So it's not a question, since I guess it's very much out of scope for this session, but it would be absolutely amazing to have an advanced session that traces a select query through the code base from a client, from the client via the query parser, query pipeline, and then the transformation out to results.
This is exactly a topic for our next webinar. We were discussing with Robert, and well, if you really like it, we can probably go ahead and make it. So this is an amazing topic.
Yeah, this is, and I think that one of the questions that I was actually going to ask you, and I was going to, point to this myself, was besides that, this is obviously a great way to understand the internals. Are there other things you could point to that would help people who would, in fact, Malik just asked the same question, that would talk about the code architecture? I mean, there's stuff on the website. Maybe you could just summarize the places people can go to learn about how ClickHouse works internally.
The first one is the great talks by Alexey Milovidov and ClickHouse team and other people, which you can find on ClickHouse YouTube channel. Unfortunately, most of those in Russian, but I guess you can find some English talks too. Another thing is you have to, probably the most valuable thing to learn about ClickHouse is to take a look how other people implement stuff. For example, if you want some specific feature, you probably go ahead and figure out whether or not something similar already exists in ClickHouse. And then you can go ahead and dig up the pull request which actually added the feature. And then you can go ahead and mimic whatever you want and mimic the existing feature and existing pull request as much as possible.
Yeah, and definitely, I don't have the link here, but Alexey did an amazing talk on C++ performance, I think about 1.5 years ago. I think he did it in China right before COVID. It definitely, Alexey, and because ClickHouse is so focused on performance, looking at his talks where you can find them in English is very, very helpful. And a lot of times when PRs do get rejected or sent back for more work, it has to do with performance. That's a strong criterion for reviewing code and accepting it.
Yep, agree. Well, yeah, as I said previously, Alexey Milovidov gives a lot of really insightful and great talks, and you should probably go and check out ClickHouse YouTube channel, which has a lot of useful info.
Yeah. Meanwhile, we'll schedule that webinar. So Vasily, it sounds like you'll be back for a return engagement in a month or so. We'll figure out when we can put that in. I think we may be running out of questions here. Feel free to add more. I want to just say a couple things though before we close. One is that just to reinforce what Vasily said, we're hiring. So if ClickHouse is an amazing piece of software. I'm not a C++ coder. My background is much more Java, Python, TypeScript, things like that. But C++ code inside ClickHouse is the most readable C++ I've ever seen, and that's saying a lot because it's not a language known for that, known for readability. So it's really fun to work on. We are hiring. If you feel like this is something you're deeply interested in, and you just want to learn the best, learn how to work on the best analytic database on the planet, give us a call because we do that full time. The second thing is we are organizing a conference. It's called OSACon, and you can check it out on the Altinity website. We just opened up signups today, but that conference covers not just ClickHouse, but it's across all, sort of the major low latency databases. We'll have presenters from Pinot, Druid, quite a few Imply folks are there. We're talking about ingest. We also have discussions of visualization. So definitely check that out as well. Signups are there, and the goal is to present, kind of get synergy, as much synergy as possible across the entire analytics community. Get the people, working on the projects like Alexei Milovidov of ClickHouse and John Merlino from Imply and other folks, get them together talking about what they're doing and sharing information. So we'd welcome you and love to have you join us. I think at this point, it looks like we're at the top of the hour and we've run out of questions. Vasily, thank you so much for a wonderful talk.
Thank you, Robert. Thank you guys for attending this webinar. And I guess all the slides will be distributed a bit later, so you can check out all the samples and the bonus materials too.
Yep, watch your emails. You should see it within the next 24 hours. If you don't see it or have further questions, contact us at info@altinity.com, and we'll look forward to hearing from you. And good luck with ClickHouse.
See you guys. Goodbye.
All right, bye-bye.